Well, good afternoon, good morning, or good evening, depending upon where you are in the world, and welcome to today's DevOps.com webinar. I'm Charlene O'Hanlon, moderator for today's event, and I welcome you. As always, we have a great webinar on tap. I'm really excited about this one, but before we get started, we do have a few housekeeping items we need to go over. First of all, today's event is being recorded, so if you miss any or all of the event, you will have the opportunity to access it later on. Following today's webinar, we will be sending out an email that contains a link to access the webinar on demand. And we are taking questions from the audience. So if at any time during today's presentation you have a question for our speaker, please don't wait, don't hesitate. Just use your GoToWebinar control panel and submit your question, and we'll try to get to as many as we can near the end of today's webinar. Also happening at the end of today's webinar, we'll be doing a drawing for 4 $25 Amazon gift cards. So please stick around. Hopefully you'll be one of our 4 lucky winners. All right, with that, let's go ahead and kick off today's webinar, which is I have an SLO. Now what? Our speaker today is Alex Hidalgo, who is the Principal Site Reliability Engineer at Noble 9. Alex, thank you so much for joining me today. Really appreciate it.
Happy to be here.
All right. Well, I know you've got a great presentation on tap, so I'm going to take myself off camera, put myself on mute, and let you get right to it.
Sounds good. All right, welcome everyone. So first, I just want to start off with a brief introduction. Who am I and why should you be listening to me? My name is Alex Hidalgo. I'm currently the Principal Site Reliability Engineer at Noble 9. Previously, I spent time at Squarespace, and before that, I was at Google for a long time. And my career's been pretty focused around SLOs for just about half a decade straight now. So first, before we get into the meat of what to do with SLOs, let's just take a brief little journey about why we need them in the first place. And it's because we have so many services today. We have things like platform as a service, or infrastructure as a service, or monitoring as a service, network as a service, database as a service, and none of those even touch upon the most common acronym, SaaS, which can stand for software as a service, or security as a service, or search as a service, or storage as a service. And outside of this, we also many people have adopted a microservices approach, where you have services that depend on other services, that depend on other services, that depend on other services. So how did we get here? How do we end up in these situations? Let's just talk about what a modern web app or something similar may look like. So someone comes up with a new idea and they write this app and they put it out on the internet and people start connecting to it and start using it. And as usage grows, suddenly realize that this app has to be distributed in some way. Just one Kubernetes pod or one VM just wasn't cutting it anymore. So now we have multiple versions of this app all running at the same time. And because of that, you need some kind of load balancing solution. Doesn't matter if this is hardware, software, or even just DNS round robin, something has to make sure that the traffic is fairly evenly split across this distributed app. And then as time goes on, realize that local storage isn't really feasible anymore, so now you need a database. And then someone comes along and adds a brand new feature, and this turns into a brand new microservice. And then another microservice is introduced representing another new feature, and this also has to talk to the database. And then some more features are added over here, as the team grows, as more developers are brought on board. And then you realize that the database has to be distributed too, because things are not going to remain reliable with just one chart of your database. And then some more features are added, and someone realizes that over here, these are all really kind of interrelated. So you put a kind of smart proxy in front of it. So the app only has to talk to a single API to enact any of these features. And then you realize you need an outbound proxy as well to handle talking to your vendors and your own SaaS solutions. And then a bunch of other features are added over here, and this just grows and grows and grows. And before you know it, you end up with a mesh, you end up with a web, you end up with deep, deep, deep dependencies. How do you figure out what's actually going on here? So you start to ponder this and you add some logging. So now, everything's logging, but you realize that's not quite enough. So you add some metrics. Now you're getting time series data. And this still isn't enough, so you add tracing. And you have all this data coming in now, but what do you actually do with this telemetry? How can you use it effectively? So the answer there is what I've dubbed the reliability stack. At the bottom, you have SLIs, or service level indicators. So a service level indicator is just a measurement from your user's perspective that tells you how your service is operating. It can't just be a single metric. It can't just be a few log lines. A good SLI really needs to be looking at what does this look like from your user's perspective. Very often you have to aggregate it, or it's some kind of combination. It's going to depend entirely on what your situation looks like, what your telemetry looks like, and what your service looks like. But the point is, very rarely is a meaningful SLI just error rate. Next on the stack, you have SLOs, or service level objectives. They are informed by your SLI. And the service level objective is just a target percentage. Right? If your SLI is able to tell you, are we currently being reliable for our users, or are we not being reliable? An SLO is just how often you want that to be true. This is also often where you can introduce thresholds. So you can say stuff like 95% of all requests need to complete within 200 milliseconds, whereas 99% of all requests need to complete successfully within 400 milliseconds, things like that. One of the most important part about SLOs is that nothing is ever 100% reliable. So SLO lets you pick something more reasonable. And this is because 100% isn't just impossible, it's too expensive to try. The closer and closer you get, the more you're going to spend financially and also in human resources. People often don't take the time to really think about what does it mean to try to be 99.99% reliable, or 5 nines, right? Leadership often wants to see things very, very close to 100, but it turns out that's just incredibly, incredibly expensive. And it also turns out that your users generally don't actually need that. People are okay with occasional failure. And then finally, at the top of the stack, you have error budgets. And the error budget is basically just a way to calculate how your SLO has performed. You generally use some kind of time window for this. So you can say, how have we worked over the last week, or the last month, or the last year? And error budgets, they really help you have better discussions. That's what they're really all about. But they also let you do things like turn your actual numbers into data that it's easier for humans to wrap their heads around. So the example we have here at the bottom, if you have a target percentage of 99.9%, that means you have a 0.1% budget. What this means is that's how often you can fail before you say, okay, now things are not good enough. And once you have this 0.1% budget, you can also convert this into a more narrative form. You can say, we can be performing unreliably 43.2 minutes every 30 days. This is just a little easier for people to wrap their heads around, for humans to wrap their heads around, as opposed to just the number 0.1%. Now, you've probably also heard of SLAs, or service level agreements. They're often informed by similar SLIs. They often have their own error budgets. I don't talk about them. SLAs are a totally different realm. They involve contracts, they involve your legal departments. It's just a whole different thing. And so the reason that this works, why it helps us measure multi-component services, is because it measures the entire service's reliability, not just how a single binary may be doing. And you have to remember that your service only has one job: do what the users of the service need it to do. There really isn't anything else. And that's what reliability really means. Are you doing what your users need it to do? But don't forget, only do this often enough and well enough. Don't spend too much time, don't spend too much money trying to be better than you have to be. And at the end, this whole approach, if done correctly, can lead to many different happier people. You'll end up with happier users because you're measuring what they actually care about. You'll end up with happier engineers because you no longer have to page on spurious error rates. If you know that you're still operating well enough, that your users are happy, don't worry about it. And you'll end up with happier product teams because you end up measuring exactly what they want you to. An SLI is really just a different form of a user journey. And you'll likely end up with a happier business as well, because you won't be spending way too much money trying to do the impossible. Okay, cool. So we've got the basics down. We have an idea of what an SLI is, what an SLO is, and what an error budget is. But what do you actually do? So the classic example from the first SRE book is, if you have error budget remaining, you have surplus error budget, ship features to your heart's content. And if you run out of error budget, stop everything and fix the reliability, whatever that may actually mean. And I don't love this. It's a little antiquated, and it relies on a kind of more old-fashioned idea that you have, an ops team and a dev team, and that they're butting heads. And I don't find that to be too true anymore in 2020. So let's instead talk about a list of things you can do with your SLO data. And I was being a little harsh on the previous slide, because the first thing in our list is, in fact, maintain a balance between shipping new features and focusing on your reliability. So let's go back to this example. The idea was that you have a kind of prototypical development team, and their job is to ship new features. Right? They plan their sprints carefully, and they're trying to ship as quickly as they can. And then on the opposite side of things, you have an operational team, like some kind of SRE team, someone who's responsible for keeping stuff running, and they want to push back on this. And there's nothing really wrong with this. But just make sure that you are careful when you use this approach. It is true that most failures are caused by changes to the environment. So it is true that sometimes maybe if you've been acting unreliably enough, you say, stop, halt, maybe we don't ship this feature right now. Maybe we need to be working on some other things. And it is also very important to remember that reliability is a feature. But I've seen this happen too many times, where this kind of strict approach can cause a kind of back pressure. So the SRE team says something like, okay, we've burnt through our error budget, stop. And the dev team's like, okay, cool, we won't ship features for a while, but that doesn't mean they're going to stop working on them. And then you end up with a whole bunch of PRs built up, and suddenly you have your error budget back, and all these changes go out all at the same time. And then you burn all your error budget again because some change broke something. And then you're out of error budget again, and then you say, okay, we're not shipping any features, and this just ends up a perpetual cycle. The point is to be smart and use this data to have good conversations. Don't always say we're out of error budget, we have to stop shipping features. Maybe sometimes that's the right approach, maybe sometimes it's not. Maybe it's never the right approach for your particular service or your particular team. The point is you can use this data and say, what should we do next? The second thing you can do with your error budget data is you can determine the focus of your project work. And a good example here is that, again, reliability improvements are features in the first place. So let's say you run out of your error budget, you can use that to help you plan your next sprint. Or maybe you don't even run out of it entirely. You notice that, we've burnt through 10%, and at this pace, maybe we will be out by the end of the quarter, like something along those lines. And use that to say, okay, maybe we need to be working on this instead. And this is also important, that it's better to think about your project work focus. It's better to think about things in this way as opposed to the prototypical devs want to ship features, the SRE or operations teams want to push back against that. And that's because not everyone owns the code that they run. Right? Think about all the open source stuff you have. You have your databases and caches, and maybe you're using Envoy or Kubernetes. Oh, Prometheus, we could go on and on. A lot of your infrastructure is often going to be running on open source solutions. And that means you can't just say, okay, cool, don't ship feature. What does a feature even mean in this sense? Unless you fork the code base, you probably have to wait for external developers to fix certain problems. So just use this to think about what can we do to make these services more reliable. That doesn't necessarily involve code changes. It's also important to remember that SLOs themselves can be project work. They're not something you do once. They're a different approach to thinking about reliability. So you're always going to have to be tweaking things. So things like figuring out how to get a better SLI measurement is project work. Picking better SLO thresholds. What are your targets actually? That is project work. This often involves a lot of math and some statistical analysis of things. You really need to think about this and make sure that you're assigning people the right amount of time to make sure that you're measuring things in the best way that you possibly can. And looking at how you're measuring things and assigning people actual project work to figure out how good are our measurements right now. One of the reasons this is important, because they're often wrong. If you accept that 100% is impossible, that means your measurements are not going to be 100% perfect either. So a quick example of how this works, you have a weekly sync. Your team gets together and just discuss how things are going and what are people's blockers and things like that. And in this weekly review, you take a look at your error budget status. And in this particular weekly review, you've noticed that you've burnt through a lot of it. But when you go ask a neighboring team, someone who actually depends on your service, they're telling you that they're actually fine. And if that's the case, then you're probably not measuring things quite right. So an example here, assign someone in the next sprint to take a look at your measurements and look at your target and what can you change them to. The third thing that you can do is you can better examine your risk factors than you may have been able to do in the past. So one of the reasons why is because error budgets let you better understand when you're not being reliable, even for very short amounts of time. So while you never or likely don't want to page off of a single 500, a single error, you can use error budgets to let you know that you've burnt a little bit of it, a tiny little bit. And what that can do is over time, it gives you a better idea of how reliable you're actually being, because you may not page or you may not alert until you've had X number of errors, X percentage of errors over Y minutes, but that doesn't give you great data for these tiny little intermittent errors. And what this allows you to do is figure out what your risks are, because when you're burning error budget at certain times, you can use that to figure out what was changing then. This is also why you need really good observability, not monitoring, right? Monitoring is great and is needed for many things, but observability allows you to know what changed. And you can use error budget burn periods and line that up with your observability and look at what changed at that particular time. And that can help you figure out what you need to fix. So an example here, let's say you have a fairly large service. It runs in 50 pods and you can't bring everything down all at once when you're doing a new release. And so you do this in a rolling manner. Pods are updated maybe 5 at a time, or maybe even just 1 at a time. And you've never heard complaints during these release periods, but your error budget does show that you're burning a little bit of it every single time. So what can you do? Well, you can proactively figure out, maybe we just need to slow this down even more and do our releases even more carefully. This is just one example, of course, but if you're never hearing complaints, yet you're still acting less reliably during these release periods, it's really error budgets that give you the best way of figuring this out. The fourth thing you can do is you can justify or delay experimentation and chaos engineering. So to understand your systems, you have to understand how they will respond under certain situations, even if they're not ones that you ran into before. Doing things like experimenting and performing chaos engineering and breaking your service on purpose even, these are all great. And the reason we bring those up here is because error budgets let you know when to do this. You can look at your error budget status and say something like, cool, we have been 100% reliable recently, so let's go ahead and try that thing out. Or you can say, uh-oh, we've burnt through 90% of our budget, maybe we should hold off on this. But the other cool thing is error budgets better let you understand where on the curve stuff starts breaking. So you don't have to wait for a full outage. You can try something small, some small experiment, flip some flag, and see, are we burning more error budget now? It doesn't have to be that you're hard down. You can now figure out, when we do that, things get a little bit worse, or they get a little bit better. So good examples are things like, do you want to try a new algorithm, a new garbage collection method, change your cache retention configuration? What happens if we move from 1 hour to 2 hours? The examples here can be endless, but it's just, like another little example of how you can use this data in a better way. So a good example, you have this pretty old Java service and it's always used a concurrent mark and sweep garbage collection method. And you've heard rumors that for your version of Java, using G1GC is supposed to be a pretty good improvement. But how do you figure out when to give that a shot? Well, in this scenario, your error budget has been great. You haven't been burning too much of it. You know that you have an easy rollback process, so you just do it. You don't need to plan this out too much more. You just change that flag, restart things, and see how they run. And if you then start burning error budget, you know that maybe this isn't the right move for you, or perhaps everything stays the same, or perhaps things improve. This is easiest to see with a service level objective approach. The fifth thing you can do is kind of related to what we were just talking about, but you can better schedule your load tests or stress tests or things along those lines. So this is kind of conceptually similar to running experiments, but you often have a more concrete goal here. That you're really trying to figure out how many requests per second can we actually handle before we break. But again, what's neat about an error budget approach is where on the curve does stuff break. So what I mean here is as you ramp up your stress test, let's say your service normally takes about 100,000 like requests per second. So, but you dial things up, and now it's taking 120,000 per second, and everything's still fine. And then at 140,000, suddenly stuff starts to creep down. You start to burn a little bit of error budget, not too much yet. And then at 160,000 per second, everything breaks. Now you know, though, that not only will you be hard down at 160, but you start to degrade at about 140,000 per second. The other way that I think experiments and kind of these exercises are a little different. Experiments can often be done by individual teams, but these sorts of exercises are often many teams working together, perhaps even the entire engineering organization. So a good example here is you have, your primary service, your primary customer-facing service runs in two data centers. One is normally kind of the primary and the other is a secondary, and you fail over every once in a while to test how that goes, but you don't know what happens if one of your data centers just goes down. Right? It could lose power. There could be a routing configuration change that's bad. It doesn't even have to be something you did, right? If an internet service provider has problems, it could look to you like your data center is down. So you want to find out what happens. It's very reasonable to want to know what happens in this case. So you spend months planning this. You bring in people from every possible team, and you finally figured out your plan. You know exactly what you're going to do. You feel prepared, and next week is the week. Except the week before, you have a pretty bad outage, and you've burnt through all your error budget. And now you're able to look at this and say, look, even though we spent months preparing for this, maybe we don't perform this black hole exercise right now. And this is really easy to talk to other people about when you have a reasonable error budget. It's very easy to have the conversation and say, look, we're out. We've said we can only be unreliable for X amount of time per month or per quarter, and we've now exceeded that. We cannot possibly do something that may break us more right now. So you use the data and say, okay, cool. Sucks we have to reschedule this, but let's do it next month instead, but only if our error budget tells us that we should. And to take this one step further, just turn stuff off, right? Kind of like a black hole exercise, but for an individual service, perhaps. And there's a pretty cool story. The Chubby team at Google does this every quarter. So Chubby is a lock serve service. So it stores little bits of data that other services can pick up on and read whenever they need to. And there are two versions of Chubby. There is global Chubby and there is regional Chubby. And the documentation states you should not depend on global Chubby. It's supposed to be considered a nice to have. And Chubby's a pretty old service, and it's pretty reliable, or at least it was while I was there. And so even though Chubby is a pretty strict SLO target, every quarter it maintains budget because Chubby just generally doesn't go down. So at the end of every quarter, the Chubby SRE team just shuts Chubby down, just shuts global Chubby down at least. Because again, you're not supposed to have any kind of hard dependency on it. And every time this happened, someone else would break. Someone would find out that they had this dependency that they didn't even know about. And even though the Chubby SRE team was very polite about this, they would send out an email, make sure everyone knew this Thursday at 3 p.m. Pacific time, we're going to shut global Chubby down. Even with that warning, people would still break even when they weren't expecting to, because they didn't know that that dependency was there. So just turning stuff down is a great way to find out about your dependencies. And in my opinion, even though it's pretty advanced to get there, any team should feel free to do this, even without communicating things out. If people understands that, you have these kind of implicit contracts, right? These aren't legal contracts, but you're only promising to be X% reliable. Don't be more reliable than that. The seventh thing you can do is nothing, just absolutely nothing at all. So I think this is important to talk about because sometimes your numbers are wrong, or sometimes you already know that you have a problem. I really want to focus on this for a second because this is where people often get things wrong. This is when people try to adopt SLO-based approaches. They think that they're mandates. They think that, okay, if we miss our SLO, we have to page on it. If our error budget is exceeded, we have to halt everything. It's always an all hands on deck situation. But then it turns out that that's actually rarely true. And then people are like, well, wait, what are these SLOs doing for us? Why did we adopt this approach? Because the data is telling us everything's terrible and we have to stop. But in actuality, in reality, we know that things aren't that terrible. So what do we do now? Maybe SLOs are terrible. Maybe we need a totally different approach. And I think that that's just using the data wrong. Everything that an SLO-based approach gives you, from your SLIs to your SLO targets to your error budget status, all it really is just data. And you need to use that data to make decisions. So like a good example of just doing nothing is, that you've been very unreliable. A great example of this is one that I've actually experienced. My team was responsible for a huge elk stack, Elasticsearch, Logstash, Kibana. And it just grew and grew and grew as more services were turned up at the company. And eventually it was just saturated. And this service all ran on actual bare metal hardware. And we just realized that the hardware couldn't keep up. We had a bunch of spinning platter disks and we really needed SSDs. But the time frame for this was going to be months and months. In fact, we placed the order for these SSDs right before the pandemic hit. And even that, it took a month to get to the ordering process because we had to request, and then a director had to, had to approve it, and then it had to go up to the VP of engineering, and then over to the finance department. And so weeks had already passed before that. And then the pandemic hit, and then nothing was being shipped anywhere anymore. And it took almost 4 or 5 months for us to get that hardware. And things weren't great during that time, but they weren't hard down either. Just the performance wasn't as good as we wanted, wasn't as good as our users needed. Log ingestion just took longer than it should have. But even though during all this time our error budget status was terrible, we did nothing because we knew we had to wait, and that's just fine. For months and months, we were out of error budget, and we waited until we got the new hardware. It's totally cool to look at the data and say, okay, maybe we don't have to do anything with it. One of the most important parts here is that you can also use this to report in your service in a more meaningful way. So let's first talk about how people report on reliability today when they don't have service level objectives. How can you do this? How can you say we've been this amount of reliable over the course of a quarter? The first thing people often do is they start counting incidents. They say, okay, we have X number of PagerDuty alerts that told us that the front end, the actual user-facing portion of our service was down or not operating well enough. And we'll get into why this doesn't work well in just a second, but then you'll often move on to stuff like MTTX, mean time to. Let's not just count the incidents, but count the average length of them. So let's talk about why counting incidents doesn't actually work. Let's say in Q1, you had 20 incidents, 20 user-facing incidents where you had to update the status page, things like that. And then in Q2, you had 10 incidents. But in Q1, these incidents actually added up to about 120 minutes of being unreliable. And in Q2, these incidents added up to about 150 minutes of being unreliable. So if you're just counting incidents, you would say that Q2 was better than Q1, but that's not the case. That's not how your users see it. So now people often move on to some kind of mean approach, right? Mean time to resolution, MTTR. which can also stand for mean time to remediation or recovery or response. People also measure other means: mean time to failure, mean time to detection, to engagement, to alert. There are so many of these. And the reason this approach doesn't work either is, well, we can use our exact same example from before. So again, in Q1, you had 20 incidents that totaled about 120 minutes of being unreliable for your customers. And in Q2, you had 10 that added up to about 150 minutes. And so you say, okay, we've learned that counting incidents doesn't work. So let's use the mean length of our incidents. So in Q1, your incidents averaged 6 minutes. And in Q2, your incidents averaged 15 minutes. And you see the problem here is that while this does now tell you that Q2 was worse than Q1 in the way that counting incidents couldn't tell you, this is now telling you that Q2 was more than twice as bad as Q1, and that's just also not true. And that's what's great about error budgets. They're great for reporting. They're great for saying how reliable have we been, because this is what they do. This is by default why they exist. They let you say over the last week, or the last month, or last quarter, or the last year, how reliable have we actually been? And this moves into the final one on our list: have better conversations. And this is the most important one. This is the absolute most important thing that I want to talk about today. And that's because, well, that's all we've actually been talking about. Everything on this list are just examples of using your SLO data, using your error budget stats to have better conversations with people. By being able to have better conversations with this better data, you can hopefully make better decisions. Don't forget that everything is always about the humans, right? Use this data to figure out who needs to be working on what and when. Use this data to figure out, are we being reliable enough for our customers? Use this data to figure out whether or not you need the entire organization to focus on a new project, or maybe just a single team, or maybe just a single human on that team even. But make data-driven decisions, and you make good data-driven decisions with the best data that you can possibly have. And that's all SLOs and error budgets really are. The most important part of an SLO-based approach actually isn't the SLOs at all. I've been talking a lot about error budgets here and how to use them, but the most important part is actually just the SLIs, the service level indicators, because they tell you, are our users, what is the experience for our users? Because that's what you're now measuring. You're no longer looking at just pure error rates or just latency or things like that. A well-crafted SLI is an entire user journey. And that's the important part. SLOs and error budgets, they're just some pre-done math. They're just taking your SLI, the most important part about all this, measuring what the humans care about, doing some math on it so that you can have these conversations easier. So I wrote a whole book about this. I'm very proud of it. Please go check it out. And that's all I got for you today. Please let me know if you have any questions.
All right, guys, there's plenty of time for questions. So if you have one, go ahead and use your GoToWebinar control panel and submit your questions. And we'll go ahead and get started. Here's the first question. When do we not know the definite, when we do not know the definite SLO, or say, I don't know what is the impact of the service if it does go down, how can someone determine the thresholds?
So I think this is asking when you don't have enough insights to actually understand.
Yeah, probably.
So a thing that I would advise here is that SLOs are just objectives. They're not agreements. They're not written into a contract. And so what that means, you can change them whenever you need to. You're probably not going to pick the right target, even if you have all the best data. So get started with something. Pick something that you think is reasonable. Pick something that you intuit that your users may need from you. And if you find out down the road that that target is totally off, it may be too strict, it may be too loose, that's fine. You've now learned this, but you need to start measuring it first before you can figure that out. I often tell people, if possible, take the time to develop a good SLI first. Once you have that, measure it for a month, and then take a look at, what was your mean value here, and what is maybe like the first standard deviation. What did our 95th percentile versus our 99th percentile look like? Do we have a long tail? Do we have, right? Just measure it first, and then you can perform some math to try to pick a good target. But the point really is just, again, kind of what I was talking about at the end. This is a different way of gathering data. And if your first shot at it tells you that you're not measuring correctly, or your first shot at it tells you that you've picked the wrong target, then that's good. You now have that data, and you now know we need to go change this.
All right, great. Next question. I think this one might actually be related. What if my SLI/SLO are breached every time because of the underlying downstream services? How do we set it to exclude the causes because of some other underlying service?
Well, I think there's two potential answers here. One, if it's your downstream service is only being 90% reliable and you have a hard dependency on it, you simply can't be more reliable than 90%. So maybe that just needs to be your target. Now, if that's not the case, right? If you being only 89% reliable is just not good enough for your users, and you know that you should probably be 99% reliable, right? Something like that. Getting started with this gives you better data to go to whoever manages that underlying dependency and say, look, we need to be this reliable, but I have this data. Because of you, we've only been able to be this other amount of reliable. And now you have numbers. And you can now go to this other team if it's someone in your organization and say, we really need this fixed. Or you can go to leadership. Maybe it's a vendor, right? Maybe you need to switch who your vendor is. And again, this gives you better data to go to your leadership and say, look, we need to be 99% reliable and we cannot. And here's the data, because we cannot maintain our reasonable error budget over even a month. Something has to change. So I think that's the basic answer, is just, even if it's someone else's fault, and I don't like the word fault there because I don't want it to sound blamey, but just start measuring anyway, because again, this is just about having data, about having better conversations with people. And once you have this data, you can go to whoever may be able to fix that downstream dependency, and you now have better proof for why they need to fix things.
All right, great. Plenty of time for questions, guys. If you have one, go ahead and use your GoToWebinar control panel. Next question, can you give a flavor of what the Noble 9 product is about? So a little product pitch there.
Sure, yeah. I don't want to turn this into a full-fledged product pitch, but it is worth talking about, I think, because we're kind of approaching a problem that I don't think anyone else has really truly solved yet. So in this talk, I've talked very kind of abstractly about, because we just don't have time to have like a 4-hour workshop and get into all the nitty-gritty. We just kind of talked about, measure SLIs and then set a target percentage and then calculate what your error budget is. But that's actually difficult because most monitoring solutions can't do that. They just can't at all. If you're running Prometheus, for example, right? Like, you would have to build a new system to help you do that. And large companies like Google have the resources to dedicate entire teams to building these SLO calculation and error budget databases that keep track of things over time. And the math can sometimes be complicated. We only talk about very simple things here, but sometimes you need to transform your data in ways that you'd have to write a whole new service to kind of sit in between and do that analysis and data transformation for you. And yeah, a few of the monitoring vendors, if you're on Datadog, they give you very basic SLO calculations, but you can still only perform that math on your Datadog metrics. So Noble 9's solution is to stop people from having to build internally the tools they need to do this math. Send us data from anywhere, everything from a MySQL database all the way to your Datadog or whatever, your tracing data, your time series, your logs, whatever they are, and we'll do that math for you. So you don't have to write your own internal SLO service.
Cool. All right. Next question. Actually, let's see. Yeah. Okay. So our group has started with counting incidents, but as you pointed out, and I've suspected, there are some issues with doing that, or at least something could be better. Any suggestions about how to start to open discussions with top management about how services would like to be judged by SLI/SLO instead of by number of incidents?
This is going to depend heavily on what your leadership looks like and what your organization looks like, because I think you have two different approaches. One is just start measuring things in a better way and figure out what your error budget status really looks like. As I just mentioned, you often can't do this with your current monitoring tools. So to start off with, you may have to do some manual math in a spreadsheet or, like whatever it may be to say, look, over the last 30 days, here's how reliable we were. So you can either go to them with that data or use the example I had here. I have a very lengthy version of this that's, I think, 15 pages, like in the book. The very last chapter of the book is basically written to convince people that this math is just too fallible. So go to them either with data that you've actually measured or with the argument I make. And I'm not trying to pitch the book here either, right? But like chapter 17, just give that to them and maybe that can help. But on top of all of that, people like stories. I think humans are often, as engineers, we often think that just numbers, are important. And we've already talked a few times about how you can use your error budget data to go to other teams. But you can also craft a narrative around this, right? Be like, your incident counting says that we've been this unreliable, but here's how the teams have actually been feeling. Here's how the teams have actually experienced this. And here's how we're pretty sure the users have experienced things. So try to craft a narrative around the data.
All right, great. Here's a question, and I hope I'm actually setting it up correctly for you. Excuse me. Which one of the following will be your choice if you have a choice between new product versus old product, new features when you are on the brim of the error budget threshold?
I don't think there's a single good answer there. It depends on your situation, right? The whole point of this whole talk is have this better data to have better conversations, and it could be one or the other. It depends. I know it depends is not always everyone's favorite answer to questions in these kind of, like in these kind of situations, but that's what it is. For some teams, for some organizations, it may be the former, and in other situations, it may be the latter. The point is having better data available to you to help you make that choice.
All right. Okay, next question. If you have to define SRE for an organization in one line, what would that be? Is it a cultural shift or a technical advancement or anything else?
Well, I'm going to have a few sentences, unfortunately. I do think it's a cultural shift more than anything else. And actually, there's another book coming up, 97 Things Every SRE Should Know, that my good friends Jamie and Emil, edited, and there's a whole ton of authors. And my very first, I'm the very first chapter in there, and it's all about what SRE actually is in just 500 words. So again, a little longer than the sentence, but basically what I say there is that SRE are people who collect data, look at it, analyze it, then make decisions based upon that. And then once they made that decision, go back and look at your data again. What changed? And it's really just that loop. It's the measuring. And I use measure there specifically. I'm not talking about collecting, right? You don't collect enough flour to bake a cake. You measure it, right? Or you're going to have a terrible cake. So that's really what SRE do. They measure things carefully, use the data they get out of those measurements to analyze it, to make a decision. Once you made a decision, you act on it. And once you've acted on it, you reflect. You say, what changed? And maybe it's nothing, and maybe things were worse, or maybe they're better. But whatever it is, you then go back to the beginning and you make your measurements better, and you collect these measurements, and you you analyze them again, you make a decision again, and you act on that decision. That's really what I think a good SRE team does.
All right, cool. Plenty of time for questions, guys. If you do have a question, we have, at least another good 10 minutes. So don't be shy. You can go ahead and use your GoToWebinar control panel and submit your question. Here's another one. Do you think SLOs are applicable to any company size, even small ones?
Yes, and that's because everything about an SLO-based approach is actually already kind of true, even if you don't realize it yet, right? You do want to be measuring what matters to your users. I think that's like universally true. Mathematically and just practically in the real world, you're never going to be 100%. So try to be good enough and pick a number that's actually closer to what reality looks like. These are all things that are true. Now, does every company have to formally adopt an SLO-based approach in terms of formal SLI measurements with formalized SLO targets that you actually measure against each other via an error budget and all that? No, I don't think so, right? It makes it easier for you because you now have this better data that I keep talking about. But an SLO-based approach, it's just talking about what is the objective for how good I want my service to be. A great story that I've shared quite a bit, but it's 100% true that I think kind of illustrates this well is right after I signed the book deal, I was getting my haircut, and my hairstylist is a good friend of mine. And so I told her, like, very excited that I signed this book deal, and she asked me to explain what it was about. And so I, like summarize it. It's about service level objectives. It's really about, not trying to be too good and only being good enough, and how everyone ends up happier if that's the case. And so she told me an anecdote of her own. When she first graduated from cosmetology school, school had ingrained in her to try and be perfect. And this meant that a 30-minute men's haircut was taking her 60 minutes every time because she was trying to be too meticulous. She was trying to make sure everything was perfectly even and not a single snip was missed. But this made her customers upset because they were supposed to be in and out of the door in 30 minutes. And it made the customers scheduled after upset because now they had to wait for their appointment. It didn't start at the right time. And since they were upset, her tips weren't good. And the person running the salon wasn't happy. So she stopped trying to be perfect. She started being more lax. Her target went from 100% to being 98% perfect, right? Like however, you want to define that. And she now knew that she was making slight mistakes, right? From her eye, she could tell, oops, I shouldn't have cut quite that high, or, oh, it's not perfectly even, but that was only to her eye. And her customers were totally happy. I was always happy with every haircut I ever got. She moved away and I miss her, immensely. And so when she stopped aiming for perfection, when she aimed for what people actually needed from her, well, they were now happier because they were in and out of the door quickly enough. The customers afterwards didn't have to wait as long. It was better for her bottom line because she was getting better tips. She was less stressed out. The owners of the salon were happier because they were getting better reviews on Yelp. And this is how things work, right? SLOs specifically are a way of gathering this data for computer systems, but every service being provided everywhere is the best version of that service is one that isn't straining to be perfect and is just good enough. So that's kind of a long answer, but I think that's why I say yes, any company of any size should be adopting an SLO-based approach in terms of caring what your users actually need, caring about what your customers actually need from you, not trying to be too perfect because that costs too much, and then making better decisions about when you haven't been perfect enough. Does that mean every company needs to expend all the time to do all this math? That's, I think, up to you. I think it makes all of this much, much easier on you. But at the end of the day, the point is, make people happier by not trying to be perfect. And I think every company of every size is already doing that to a certain extent.
All right. Excellent. Excellent. All right. Next question, how do we influence a resiliency decision once we have good or acceptable SLIs that show us we are not as resilient? We are reliable though, as we thought we were.
This again is unfortunately going to be it depends because too much of this is based upon the culture of your organization, of your team. I can't possibly know what the pushback has been in the past. The best advice I can give in just a general sense is going back to the fact that, again, people like stories. We talk a lot about using the data to make decisions, and I think that is also very important. But when you need to convince someone, I think stories are better. Humans are storytellers. We always have been. It's how most people our best influence, right? I often tell people, I know just earlier I said that like SRE are data collectors and analyzers, and that's very true, but I also think a good SRE is a good marketer. You need to know how to go to other people and tell them stories to explain why they may not have the right view of the world. So that's the best general advice I can give without knowing all the nitty gritty of your current culture and how your teams currently talk to each other and stuff like that. Is remember that stories convince people better than just numbers.
All right, good enough. Okay. Okay, time check. We're about 10 minutes to the top of the hour. I think we have time for a couple more questions. Next one, how do you calculate the SLI for services which are very critical but have low transactions request, such as replacing damaged credit card service, which need to have high uptime and otherwise a very low transactions?
Yeah, this is a great question. This is difficult to do. This is another thing that we're trying to solve over at Noble 9, actually. There are ways that you can do this, but I think at the root of your problem is something along the lines of if you only have 5 data points per hour, one of those is bad, it suddenly looks like you're only being 80% reliable when that's not really what's going on. And there's math you can do. You can there's various binomial distributions like that you can use to to do this better. Poisson distributions can help you think about the probability better. There's plenty of math. There's 16,000 words on this, like in the book that I didn't write, by people much smarter actually. Or at least that know that math better. So that's the best way I can answer it in just a few minutes in this kind of scenario is I understand your plight. I've seen it many times. You can do it. You just have to go find the right statistical tools to help you extract the best data out of your SLIs. And that way you have a single miss. You can figure out probabilistically what your actual reliability was over that period, as opposed to the 80% that just the 5 counts might tell you. So it's not easy. The math can get complex, but there are ways to do it, and people have written about how to do it.
Excellent. Okay. All right. I'm going to give you one more question, then we'll close out the question and answer period because I don't want to. You've been answering questions for so long, so I want to give you a bit of a break. Does your book talk about SLIs for resiliency measurements as well?
Not specifically. I do talk about resiliency in connection with reliability in chapter 2, but I don't specifically tie SLIs to it. I talk about it in a grander conversation in terms of what does reliability mean. I think it's very wrong to think of resiliency and reliability as like separate things. You have to be resilient to be reliable, right? It's part of that picture. So chapter 2 is entirely about how to think about reliability, and I do talk about resiliency in there as well. So not in the sense of how you framed your question about tying SLIs to them specifically, but I do talk about it that, well, yeah, I guess I do. I think resiliency is part of reliability. So it's really just part of the whole story.
All right, great. So we are about 7 minutes to the top of the hour. I'm going to go ahead and close out the question and answer period, but if you do have a question for Alex, you can still use the GoToWebinar control panel, and if we have any time right at the very end, I'll go ahead and throw that question out. But for now, I do want to thank everybody who did submit questions. We had a ton of them, and I was really impressed by every single one of them. So thank you to everybody who did submit questions. Also, a quick reminder that today's event has been recorded or is being recorded. So if you missed any or all of the event, or if you just want to watch it again, you will have the opportunity to do so. Following today's webcast, we will be sending out an email that contains a link to access the webinar on demand. And the webinar is also going to be living on the devops.com website, so you can always go look for it there. Just go to devops.com/webinars, look in the on demand section, and it should be right there waiting for you. Okay, all right, so I did mention at the top of the hour we'd be doing a drawing for 4 $25 Amazon gift cards. Let's go ahead and do that real quick. Our first winner is Deborah W. Congratulations, Deborah. Our second winner is Clint C. Congratulations, Clint. Our third winner is Jennifer F. Congratulations, Jennifer. And our final winner today is Tom W. Congratulations, Tom. We'll be following up with all 4 of you by email after today's webinar to get your Amazon gift card over to you. So please check your inbox. If you don't see it there, check your spam folder. All right, Alex, it looks like that is no more questions coming in. So I guess that's going to be the end of it. So I do want to thank you very much for your time, your expertise, lots of great information in this webinar. And judging from the questions that came in, I know the audience got a ton out of it. So thank you again. I really appreciate your time, as I said, and your expertise.
I had a great time. Thanks so much for having me. And the last thing I'll say, come find me on Twitter, A Hidalgo SRE, AHIDALGO SRE. And feel free to ask me questions there too. I will tell you up front, I may not answer if I'm too busy, but I try to help people out there as well.
All right, great. Well, thank you very much again. I also want to thank the audience for joining me today. This is Charlene O'Hanlon, and I'm signing off. Have a great day, everybody. Please stay safe.